So I'm going to lecture a little bit, then I got a handout for you guys to work on related to this. And what we're finally getting into, and I'm going to make a semi-promise to you. That is that I'm not going to make you do the limit definition of derivative. There might be something on the final exam, like one problem, and there will be a few proofs that we do in class together that will involve it. But from this point forward, we're going to talk about the simpler ways to do derivatives. Right? We've already got one rule that we haven't officially proven, and that's for functions like this. Who knows how to apply that rule correctly that we sort of talked about a little bit? Anybody? Yell it out. I like it. So that comes down, and the power goes down by 1. So let's take a minute and try to prove that. All right? And I'm going to prove it. They got it in the book for the most general case. So if you don't know your combinatorics, if you don't know all that stuff, and it uses Pascal's triangle, all that kind of crap, I will show you something that gets a little more directly to the point. And it's actually on the handout too. Does somebody have a question? Yeah.
No, I thought you were asking for us to tell you.
Oh no, that's there. So somebody help me out. If I wanted to find this guy's derivative, what would I need to do? How does that work? To use the limit definition.
X plus n minus 1.
So what's got to go first?
N?
No, come on now.
Oh.
I mean, define it using the definition of derivative. It would be f prime equals the limit.
H approaches 0.
Yeah.
X plus h reduces to 8 minus the function over h.
Alright, cool. I like it. That's the basic idea. And of course, when you guys did it on the test, you were leaving a few things out, possibly. You gotta have that limit in there. The h can't suddenly disappear out of nowhere. You've got to have that reason why. But now, what's f of x plus h? Here, I'll do this much. Alright, now you guys figure that out. No, come on. If we go this route far enough, why did x pick 8? We can go back to
X to the 8.
Exactly.
Okay. Because here's the point. Now, I talked a little bit about Pascal's triangle and talked a little bit about binomial expansion. It really kicks a lot of ass. If you still don't quite understand it, I'm going to use it right now because it just gets to the point a lot quicker. And the whole idea was, when I'm doing this, if I expand this out, the very first term is going to be what? X to the 8th. Because the first thing that could possibly happen was every x gets multiplied. And then all the other terms, the next term would basically be x to the 7 that goes down by 1. And then h to the first that goes up by 1. And then you have these tell you the coefficients. How are we doing so far? And then every other term after this, now you'll see why here in a minute, every term after that has at least how many h's?
Plus 1.
Has at least
At least 1.
2, right? Because won't the next one be x6, h squared? H cubed, all the way to h to the 8th. So everything after this is going to be, let me use this interesting notation. Sort of misusing it, who cares? On the order of h squared, at least. Screw it. So let me write it a different way on my little handout. Plus terms with at least h squared. How we doing? Now, some of you guys right now, you have no idea why the hell I wrote it like that. You have no idea why I stopped there. You're thinking God I did, right? Or whatever favorite deity you have. So that's f of x plus h. And when I plug that in, I get x to the 8th plus 8x7 h1 plus other crap, greater than h squared stuff, right? Minus f of x. You guys kind of with me? So you guys hopefully have already seen the point part of this. Divided by h. These cancel. And notice how the next term will always have a number that's 1 below the actual power involved. Actually, that's not 1 below, but is the power involved. There's your 8, and then the power goes down by 1. So watch this. Here's where the h cancels directly. There's no h's left in that term. Here, there's going to be at least one h left in every single term, and why is that important? Because I'm letting h go to 0.
Bring up the 0.
So what's the only thing? That whole thing goes to 0. Those canceled. Those h's canceled. I get 8x to the 7th. So it doesn't, I picked 8 just so it's easier to look at. Are you with me? So it's not really a proof. If you want a real proof, you can look at the book and they use their combinatorics and all that kind of crap. But they basically have the same idea of get to the point where you have more than one h, and those are going to die eventually because of this guy. So they don't matter. All that matters is really the first couple terms, and those are going to show you the pattern. Those are going to show you that this pattern happens. How we doing? Okay. So many guys are like, I don't really need a proof, Jeff, but you're always going to get something like that from me. So on page, if you want to see it all the way out, it's page page 175. Okay. So here, you guys, let's see if you can apply the rule now. The only time I would make you do anything like this would be in a bonus problem. It would be something like that. But can you apply it directly? So now when I ask you to find the derivative, it's not using the limit definition. It's just the direct application of the patterns we're going to talk about. So here's the first pattern we've established. If I have f of x equal x to the n, f prime would be
And x raised to n minus 1.
and x n minus 1. I love it. Kicks so much ass. So if I have this, you guys find f prime for these.
Here we do dy dx.
Oh, yeah, use dy dx. That's fine. So find f prime or dy dx, however notation you like to use.
Good job, dude.
Yeah.
3 is the fifth root of x, right?
Fifth root of x, yeah.
Alright.
Bless you. Oh, that's all right. Bless you. So I want to make it really clear that we're going to learn a lot of different rules for finding derivatives based on the form of the function I've been given. So if it's in the wrong form, to use a rule, but it can be put in that form, you put it in that form. So somehow that relates to one of these. Probably the odd man out. What's this first guy? I like it. Cool. So the 4 comes down, multiplies by the 3 that's already there, and then the power goes down by 1. Here, what f prime? Do it one more time. 22, I like it. So there's negative 11, negative 2 multiply, I like it. Good. And the biggest mistake there is people put negative 10 because their brain gets too stuck on making it a smaller number. You got to make it more negative. I like it. How we doing? What do you have to do with this guy first? I like it. Put it in x into power form. So then the rule applies. So what's f prime going to be?
1/5 x to the negative 4/5.
Kick ass. All right. Not too bad. Yes, sir.
Can you just leave it like that, or would you have to put the
Oh, I see. You could now, I mean, depending on what you need to do next. These are all fine if the question is find f prime, find the derivative.
Yeah.
If you have to do stuff later, the form it's in might have to be changed to make it easier just to continue.
Yeah.
So what's another form you can put this in?
1/5 x to the square root of 4/5.
What root is this going to be? Fifth root of x to the fourth. I like it. Roots are on the bottom, like they are on plants. Right? Like botanists don't bring any tubers in it or whatever. Potatoes are no, it's good. Roots are on the bottom, power's on the top. Bam. Fifth root, fourth power. Is that cool? So depending on what you have to do next, this might actually be a better format than that. Just depends. I like it. Okay. Not too bad. So real quick, what about if I had this? What's F prime?
0.
Kick ass. And don't forget that this is just a question about what? The derivative, of course, means slope. So this is a question about slope. So this sucker would be a straight line. It's got zero slope. That's why the answer is 0. If I'm given a line, F prime is like it. Don't even really have to think about it because it's just a question of slope. I like it. Okay, and this kind of has a hidden thing in it that should actually not even be a big enough deal to talk about directly, but if I have a function that's made up of several different parts, how evil do you want to be? All right. How would you find f prime? Or d f dx?
There's a sum of each one.
I like it. So each one can be treated differently because the limit, derivatives are based off of limits, and limits could attack each one of these pieces separately, right? So the derivative looks like it distributes. And what you call those kind of functions, it's not really distributing, but it acts like it does. You call those linear operators. They look like they distribute across the problem, but they're not really. So I can just treat each one separately. Like you said, this is 7x to 6.
8 over 35.
That just comes down and directly multiplies, right?
8 over 35.
So 8 over 35. Now here's the kick-ass thing about this. If you're trying to take it down by 1, here's the shortcut. You do negative 2 minus 7, negative 9 over 7. So if you're subtracting 1, you subtract these two. Isn't that what we did over here? Where'd it go?
Yeah.
What's 1 minus 5? Negative 4 over 5. There you go. Right?
Oh, okay.
That kicks ass. And that's so useful for these kind of things where your brain goes, I could hear it happening. And then that last dude, you just have to realize that this is actually 3x to the negative 1, so it becomes
Plus 3.
plus 3
X minus.
x to the negative 2. I like it. And there's several in there you can rewrite in different format. That would be fine for me. Or you can rewrite it as roots, and you can put the x to the negative 2 on the bottom. Stuff like that doesn't really matter until we get to problems where we need it in a certain format. Yeah.
I'm not confused how you did that. Can you,
Which part?
how you jump from 4 pivots to 3.
Oh, so when I apply the derivative, that power is going to come down and multiply by what's already there. So I just really have negative 2 times 4 is negative 8. 7 times 5 is 35.
Right.
Is that cool?
How'd you do minus 9 over 7?
Oh, and then this power's got to go down by 1.
Okay, yeah, there you go.
So you got to subtract 1. So that's subtracting 7 over 7. That's why the shortcut works, because 1 will always become this over itself. And that's why that shortcut works. I like it. How do you feel about that?
This is the last term is not really raised to the x minus 1, right?
Yeah, it's 3. It's, how do you mean? Sorry. If it's over x, it's definitely going to be x to the negative 1.
I thought it's raised to the x minus 1.
Oh, no. Yeah. Otherwise, that would be something we haven't talked about yet. That would be evil. Okay. So, let me give you this. I want you guys to try out, see if you guys can handle this. 1 through 3 at the bottom here. I have a little extra thing, that bonus problem about finding the derivative sign. I got it worked out here.
That's cool, right?
Lost in the backside of it, like, 30 minutes up the trail, dude. Yeah. I don't know either, dude. He was lost. It was dark. Like, we were afraid, dude. I saved it. Yeah, I walked him down the mountain and he found Stanley. He was actually lost.
What sections are
It was actually
we?
He was terrible.
Yeah.
He had like a arm, like, cast
Sounds
on.
about right.
It was weird.
Oh, sorry.
So he could go.